Welcome friends to this video. We're going to build a tic-tac-toe app in Python. This video is going to be a very basic version of tic-tac-toe. So if you're familiar with tic-tac-toe, it is a solved program or solved. Basically what that means is that every outcome can be accounted for, therefore it's very predictable. And essentially if you have two advanced players, it will always end in a tie. In this video, though, I'm going to keep it very basic, and our computer is going to choose at random just to get the application running. And then for another video, if I continue the series, then I'll create another one that kind of explains or does a better job at doing a more predictive type of algorithm. So what I have first is the design. So let's take a quick look at that, how tic-tac-toe in terms of functions should be laid out, and at the decision in the order in which it would run. And then we'll code each function, and then we'll do our run program and test it out. So let's take a look at first. I have three areas here. Here is where our run program starts. First, what we're going to do is print the board. And so basically we want to see what that grid looks like, and then we can start choosing our playing. So the next one is we're going to basically switch between players. So we're going to randomly choose if the computer goes first or if I go first, and then we'll switch each round or each turn. So then the next one after that is we want to actually take our turn. So that is the player turn, and then I'll talk about each one of these. They're a little bit different in terms of myself or the computer. We'll talk about those in a second. And then each time after we have taken our turn, we want to check two conditions, and what we're going to do is we're going to exit, and the game's going to end. So this is a loop that's going to keep running until that happens. So first of all, we want to check if we won, and essentially what that is we have three in a row, and so we'll exit and we'll output that either the player or the computer wins. If the person or player or computer has not won, then we'll want to check to see if the board is full. If all 9 spaces are taken in our grid, then we know that the game is a tie. If neither of those happen, then we'll repeat the condition and start the next loop. All right, so just to kind of give you an idea what each player does, first in the player move, what we're going to do is ask for an input from the user, and we're going to say, please play a position on the grid. And so what we're going to do is a couple checks. First, we have to check, is that position free? So we're not duplicating, accidentally playing over the top of that other position. We also want to make sure it's a valid integer that we can use, so not some, say we mistyped and said 32. So we're going to check those. If either of those happen, then we'll ask for it again. We'll prompt them and say not a valid number, prompt them again. If they do give us a valid number, then we'll go ahead and place that marker on the board. Now for the computer move, just quickly to give you an idea of an algorithm that I thought about, but essentially for this game, we're just going to choose at random. We're going to do the same checks, is it valid, and then we'll place the marker. But one way we could do this is ideally we want the computer to check to see if they can win, play that marker. If they cannot win, then we'll want to check to see is the player have 2 positions in which we can block them. And then the strategy would be to play the corners, middles, and edge. But I've highlighted that in yellow for another video. So let's go ahead and start. First, what we're going to do is I'll do my imports, and I'm only going to need random to choose who goes first and also use for the computer move. And then let's talk about the functions that we're going to use. And most of these are those boxes that we used with additional ones as we go through. So let's first outline those, and then we'll start building those functions as we go. So the first one is going to be define the board. And I did forget, I think just for simplicity, I'm going to define player and computer as X and O. Now we could also let the player choose, but for simplicity, we're just going to define one as X and one as O. And we could also use X in our code and O, but I think it'd be just easier to use player and computer to be less confusing. So I'll define those. And then we're going to need a function to define the board. We're going to need one to print the board. We're going to need one to find out is the board full in case of a tie. Then we're going to need to check to see if there is a win. Then we need to check to see is a space free, and when we're going to place the marker, we want to make sure that there's a space available to play so we don't have errors. Then we want to do place that marker on the board. So we've detected it's free. Now it can be placed on the board. Another one we want to do is find out who goes first. Then we can start our turn. So we could say player turn, and we could say computer turn, and then also switch our player. And then lastly, we can run the game and we can start the game. I think that's all of them. Let's double check. Yeah. All right. So let's go ahead and get started on building some of these functions. So defining the board, basically we want 9 empty spaces. So we're just going to loop through a range of 10 numbers and create a space. So the way we do that is have a variable board, and then we'll say in a list space and for I in range of 1 through 10. So we use 10 because it is exclusive, and we're not going to use 0 because that's not easy for us as people to, we'll just make it more easily on a grid style, 1 to 9. So that's why we'll go up to 10. All right, now we can go ahead and print the board. So we'll define a function print board, and this is going to be kind of manual the way that we do it. But what we'll do is first I will start by just doing a line separator. So when we go to print, each time a player goes, we'll just have a separator. Otherwise, it looks like one giant grid. Then we'll print our top row. And the way that we do that is we'll say board at position 1 through 3. So 1, 2, and 3 is going to be our first horizontal row. And then we'll print a line of dashes to separate that. And then in between each position, there's going to be a vertical bar in the grid. And we'll take a look at that in just 1 second. So we'll do the next row, 4, 5, and 6, print another separator, and then the last row is 7, 8, and 9. So if we do a print board here and run it, we can see what the board looks like. Here we go. This is what our board is going to look like. All right. So let's keep moving on to checking, define if board is full. So the way that we can do that is basically just look for spaces. And we can do this in a single line. So we can say return if there is not an empty space in the board. And I'll say from 1 to 10. So remember, 10 is exclusive. So we're basically saying from 1 to 9. If there's an empty space, then our board is full. All right, now we can check to see if there's a winner. So the way we would do that is, let's just call it check win. And this is also going to be a lot of manually typing, but I think this is probably the most optimal way we can do it. So the way that we would do that is I'm going to change this here to equal to player, is board at position 1, 2, and 3. So that's our top row. If 1, 2, and 3, if all of those are X and equal to player, which player is X, then we have 1. And so we're going to do that for every position. There's 8. There's going to be 3 that go horizontal, 3 vertically, and 2 diagonal. So we need 8 lines for each. And so the way that that looks is there's our next horizontal. There is our next horizontal. There is our vertical. There's our next vertical. Our next vertical. Now it's our diagonal and our last diagonal. And you can see each one of these are equal to player. However, that checks just for players, so we need to do this also for the computer. And so the way that we would do that is the same thing all over except for computer. So that would be Let me see here. What am I missing? Yeah, but okay. So let's do the next rows. Hopefully that all made sense. All right, let's see, that should do it. All right, so now we have checked every when scenario. So that's our when function. Okay, let's go ahead and check to see if a space is free. So what this does is it'll see, is there an empty space? That way, if there is, we can play. If not, we can ask them to play again. So yeah, I'll call it is free. I don't need to pass in anything, the number here. And then basically I will do, yeah, return board. And then instead of 1, actually, I do need to pass in position, because position is what we are going to give as our parameter. So we're going to pass that in and see if that position is an empty space. So that will be our is free. All right, next one is to place the marker on the board. So we'll call place marker. How's that? So marker is, we're going to set it to the position of the board, and we're going to pass through marker and position in our place marker function. Okay, so now we can do the next one is going to be who, I'll call this who goes first. And this one is going to be at random. So we'll use the random model. We'll say if the random, basically a coin flip, instead of computer, I'm going to say player, else we can say computer. So if a random number is 0, then it'll be a player as our first one. If our random number is 1, then our computer will be the first player. All right, now we can work on player turn. So player turn is, we're going to do a try and accept here. So there's, if you remember the diagram here, let's get back to that. We need a couple conditions. We need to check if available, and we also need to check if valid. So we need to do both of those. And so first, I guess what we can do is ask the player, what is the position? And we have an input. I also want to wrap that in an integer, because it'll be a number. And so we'll say, let's do try. And we'll say if position, oh yeah, we will say if free, the position is free, then we'll go ahead and place the marker. If it's not, then we'll say position's not free, and we'll ask the user to try again. And now we can do our accept statement, which is our position. Oops, we'll do another if position of less than 1 is less than 1 or greater than 9, so in between the range of 1 and 9, then we'll say this is not, we'll say, please choose a number between 1 and 9. So we use an except if they do pick like a strange letter or a typo, then it won't crash. It'll allow them to play again. Okay, so let's look at that one more time. So first, we're going to ask them for position. And then we're going to check to see if it's a blank space on the board. If it is, we'll go ahead and place the marker. If it's not, we'll say it's not free, so go try again. And also, it'll look for the if it's a character that's not between 1 and 9, it'll prompt them and say, please choose between 1 and 9, and then ask them for the player to turn it, let them play again. All right, now for the computer, it's similar. We'll want to check for is free, but instead of asking for input, we're just going to choose a random number. So we'll just say computer turn, and we'll say position equals, random 1 through 9. And then yes, we want to check if it is free, then go ahead and place the marker at the position that it just discovered with this player. And then else, we do want an else here, because if they do accidentally choose a position that is not free, then we want them to go again. So computer turn. All right, so that's the simple method of how we would get the computer to take their turn. All right, now we can work on doing a switch player. So first, what we want to do is set the current player, and we'll call that previous function who goes first to choose a random one. And now we can do our function to do switch player. And then what we're going to do is we need to set, we need to have current player as a global, because what we define inside of this function needs to be available outside the function. So we'll do global, and we'll say if the current player double equals, and what that does is that is a comparison. So if this here equals player, then we want to flip it and we want to change it to computer. And then we also want to say if it's not, let's say if the current player is not player, so if it's computer, so else, then we want to change it to player. If it's player, change to computer. If it's not player, then if it's computer, it will change to player. Okay. All right, so that is how we switch players. Now we can work on running the game. And let's do that. So first of all, we can do, we'll just call this one main. And first, I guess what we'll do is print a welcome message. And then we can start a while loop. So while true. And just a highlight here, this is kind of what we're gonna do. Print board, switch player, have the current player take their turn, check if they win, then output if they do, check if full, output if they do, and then run again. So I guess what we'll do now is we'll go ahead and print the board. So print board, and then we can then switch player, and then we can run the current player turn. Did we define the current player term? We did not. I missed one. Okay, so after switch, let's do that. We want to define the current player's turn. So current player turn. Okay, so we'll do current player turn. And what we could do is say if the player is equal to player, then we'll do player turn. Else, then it's going to be computer turn. So that's basically just going to tell us who should play based on current player. So current player up here, we're going to, down in the run function, we'll say current player turn. All right. Then, so each player is going to now start playing, and we want to check to see first if they won, then print. We need to say current player because it could be the computer. And then current player, whoever that is, win, and we'll break out of the loop. We also need to do another check. We could say is full, and if it is full, then we would say it is dry, and we'd break out, it's a draw, and then we'd break out of that loop as well. And that should do it. Let's go ahead and run the main function. All right. Hopefully, autocomplete did not give me something I did not want. All right, let's go ahead and run it. Boy, it runs on the first time. Okay, so computer went ahead first and selected that. So let's do me. That's 1, 2, and it's choosing at random. So I won there. Probably what I should do because I didn't see the results. So I'm going to add an extra line here. Print board there, and I'll print it board here as well. So in case there's a win or a draw, we can see the results. So let's go again. So, okay, I won. Okay, and I see the results. So let's play a losing strategy. 2, 4, 6. All right, so 0-1. Now it's going to be a little more difficult to play or to lose against a random one, but we'll give it a shot. I may need to pause the video just so I can show you how that works. 2, 4, 6, 8. 3, 9. All right, there is a draw. So we covered all scenarios. And just to show you the randomness there, I play first, we run it again, the computer plays first, so that works. Yeah, I think everything we covered in here is functional. I think the only thing missing is we can improve on the computer turn, kind of like what I've highlighted before, so that would be covered in another tutorial. But anyways, I had fun doing this. Hopefully you learned something and found this helpful. And thanks for watching. I'll see you in the next video. So long.